Deze podcast is powered by ACC ICT, de nummer 1 Kubernetes specialist van Nederland.
Welkom bij de Nederlandse Kubernetes Podcast, de podcast over Kubernetes voor iedereen. Ik zit hier weer alleen. Mijn partner in crime is nog steeds MIA. Nee, hij is nu niet meer aanwezig op KubeCon. En ik heb echt wel hele mooie gasten aan tafel. Die doen onder andere de Google podcast, de Kubernetes Podcast. En het is Abdel, Sghiouar en Mofi, Rahman.
Yep.
Yeah. Can you introduce yourselves?
All right. Well, dankjewel is the only thing I know how to say in Dutch.
That's better.
I also know how to say alsjeblieft, but yeah. Hi, Abdel Sghiouar. I'm a cloud developer advocate at Google. I'm one of the co-hosts of the Kubernetes podcast. And I just work on Kubernetes.
Oh, awesome.
And my name is Mofi. I'm also a developer advocate at Google, focusing mostly on GKE. And I have been a guest host at the Kubernetes podcast from Google for a few episodes, but helping out where I can.
Awesome. And how did you get started in the IT?
I started like 15 years ago. I think I am one of the people that probably could qualify as somebody who had a traditional kind of path. So going through school, like until university, master's degree in computer science, and then started working in a startup back home in Morocco, where I'm originally from. Mm-hmm. Then joined Google in 2013. And I've been at Google for almost 12 years now.
Oh, that's a long time.
Yeah.
Awesome. And
I went to school for computer engineering, graduated 2017, started working at IBM. I worked on like traditional Java application, not microservices, like Java monoliths. Like the day I joined, I remember I had to run my Maven build. It took hour and a half. First time, it was a 50 million line code base. So I've been in the weeds of like very deep Java expertise. But eventually, I found my way into IBM Cloud, where IBM Kubernetes services. From there, kind of the world of containers and container orchestration and scaling kind of became my core skill set at some point. Then I left IBM for a short stint and worked at Vonage, like video APIs, like that kind of stuff. Mm-hmm. And then eventually about 3 years ago, joined Google and it came back to the world of Kubernetes again. And that's been the last couple of years.
Oh, awesome. And you had a talk, Kubernetes, the LLM on Kubernetes.
Yeah. So go.
Yeah. So I think like when about 2022, 2023, when OpenAI released GPT to the broader public, there was a big shift in the community to run large language models in any infrastructure you can get your hands on, right? And we pride Kubernetes as a tool to be able to run pretty much anything you can think of. I think Abdel and I had this conversation in like maybe 2023 or 2024 where like, it's just apps, just run apps. Like what's the big deal there? So I think I have changed my mind quite a bit about like how and why running LLMs on Kubernetes is kind of like a different than just running any old web app. Like things like you do have to think about the resource like GPUs, TPUs. You have to think about storage quite differently. You have to think about networking quite differently. So although it's just apps, but the kind of consideration you have to be able to run large language models on something like Kubernetes does force Kubernetes as a tool to evolve to accommodate those kind of workloads. So yes, you can run LLMs on Kubernetes, and no, it's not exactly like a web app. There is some nuances there that makes it different.
But then what do you have to do then for running LLMs on Kubernetes? What is the storage requirements?
Yeah, so it could pretty much run it on Kubernetes without doing any optimization on the storage. But then you're talking about paying a lot of money for the GPU or the TPU per second or per hour that you're paying for. So if your storage is not fast enough to like load up the model and serve it as quickly, you just have a bunch of idle time where you're paying for a GPU, but your customers are not being able to use inference on your cluster, right? You want to use the fastest possible storage solution. Another like a very minor thing that people don't probably think about, when you have a web app, when you bundle it up, you can put it in a container, and when the container starts, the entire application is loaded. Yeah. But when you're talking about a large model, let's say DeepSeek, which was like a big deal a couple of months ago and still is, that model data is roughly 700 gigabyte of data. Right? You couldn't just put that in a container and easily download it, run it on demand. You have to kind of like have that somehow loaded or downloaded at runtime. Like you would go to Hugging Face, try to start the download. Now you're dealing with network over like public internet to download 700 gigabytes of data before your container can start serving traffic. right? So there are optimization you could do where you pre-download the data and like make it available before the container starts. So when the container starts, it just attaches a storage. So this is no web app in the world, I don't think, needs to have the consideration, I need to download this web app's data beforehand.
Yeah. I think at the basics, Kubernetes kind of was born from people spending a lot of time optimizing web apps, right? Running web apps, right? And we got to a place where Kubernetes solved the problem, which is obtaining capacity and resources when you need them on demand. So you have a web application, you need to scale it, we can get you CPU and memory very quickly, right? And LLMs are quite different because you need this extra thing called accelerators, like GPUs, TPUs, whatever you want to call them. And those are A, very expensive, and B, very hard to obtain, right? And so it sort of brought us back to square zero, which is the classical problem. So say you have an LLM that needs a GPU. Do you provision the GPU, run it all the time, pay for it, even if no one is talking to your app? Or do you set it up such a way that it auto-scales when traffic comes in and then scales down when traffic is not there anymore, right? And then when you talk about scalability for LLMs, then you start talking about load time for the LLM itself, especially if it's big. Load time both to download it from the disk, and then load it into the GPU memory. Getting that GPU first time, right? the obtainability problem, as we call it. So, most cloud providers claim, and we work for a cloud provider, so I think I'm allowed to say this. Most cloud providers claim that you can get like A100, and then, there is probably 10 people in the world that can afford it, right? So those classical autoscaling problems that we had with web apps that we spent years optimizing are kind of back into the picture when it comes into LLMs, just because they are special, right? And so our talk covered a little bit of the basics of how do you actually run the LLMs on Kubernetes. And then we also talked a little bit about those optimizations, the network optimizations, the storage optimizations, like faster load time, blah, blah, blah. So we spent quite a lot of time on that. And the funny part is somebody took a picture from our talk, published it on LinkedIn. And because the talk is, yes, you can run LLMs on Kubernetes, we had a lot of comments on LinkedIn saying, like, should you? Like, people were questioning, should you actually run LLMs on Kubernetes? And I think we're very, very, very confident that you should. It's just like you need to be aware of what you're doing.
And one other additional thing about how this is different. For example, in Kubernetes, in the early days, the biggest use case for Kubernetes were stateless apps that your app, like for some reason your container dies, just spin up a new one. It doesn't matter. But the moment you have GPUs, you are attached to the hip to that node. Right? You could not just say, this dies, doesn't matter, I'm going to just spin up something new, because you have all of a sudden you have some version of state. You start considering your containers and your pods more like pets than cattle that you could do before with stateless applications. There's one more thing of like, because your network, not for inferencing all that much, but for something like training, now you have to start considering not just a single node, but a group of node as a single unit of operation. Yep. You have to have like really great networking things so that you can have training across, like for example, the Llama 3 model that Meta trained, they didn't use Kubernetes at the time. Probably they should, but they didn't, but they trained it across the GPU cluster of VMs of like some 24,000 different VMs working together, right? And at the time, again, the beginning of Kubernetes, that was not a use case that people thought about Kubernetes for. But now, as like more and more things are being run on Kubernetes, these kind of things, we are in like basically evolving the Kubernetes API to handle things like this, like things like DRA and things like other additional workload like Q, an open source project that started from SIG batch, LWS Leader Worker Set that came from SIG inferencing. So these are all these projects, because the workload of running LLMs and training LLMs are so demanding, the Kubernetes, the project itself is evolving to match it.
Yeah. It's. I mean, those are just some of the projects. There is a lot of things. There is also one that we should probably mention: the working group devices or device management. Yeah. So it is like a whole group of people within the Kubernetes project working across SIGs, so special interest groups, on this thing called device management, right? So how do you actually make sure that when you run a pod and you pin that pod, do you use a node selector to say, run this pod on a node that has a GPU, that the kubelet knows how many GPUs are available on that node, and then they report back to the API server to say, we have this number of GPUs assigned, this number of GPUs available. So your classical resource management, but now we have to extend it to support accelerators.
Yeah, every device we have to extend it to every device because we have if we have printers on a node, we also need to divide that. But diving into that device management, and are they doing also something with GPU slicing? Because sometimes I just need a fifth of a CPU or a GPU.
Yeah.
Just like a CPU.
Yeah, so that's a very interesting question. So I think that the whole point of the device management working group is to make sure that device management within Kubernetes is abstract. It's not specific, right? Kubernetes itself, when it started, it had a lot of very specific stuff. Well, the very classical example is Kubernetes started with only running Docker containers. Yeah. And then the team or the community had to do a lot of work to decouple Kubernetes from Docker by implementing the CRI, the Container Runtime Interface, right? To make sure that if there is another container engine that comes up tomorrow, that Kubernetes could support it, right? And so the whole point of the device management working group is to kind of apply the same philosophy that whatever devices you need, we decouple them from the implementation of Kubernetes. So the way really it works is that the node will have a GPU.
Yeah.
The GPU plugin or the device plugin will register that GPU to the kubelet, which then register it to the API server. And in that registration flow, the API server knows what are the capabilities of this GPU. Does it support multi-slicing? How many GPUs are available? What's the configuration of the GPU, right? All that stuff. So then later when you run your workload, then the kubelet through the API server will talk back to the device or the plugin to say, okay, allocate, one slice of a GPU to this workload, or run this across 2 GPUs or 3 GPUs, right? And the examples I'm giving here are specific to GPUs, but they can be like abstracted away to any device. So they could be TPUs, the tensor processing units. Yeah. They could be printers. They could be whatever, right? Like a slice of a printer, right? Yeah. They could be any sort of devices, right? Like that's why they specifically call it device management and not accelerator management.
That's awesome. That brings up a complete different type of devices. Because in the old days we had, I don't know if you didn't know that, you had specific keys to run your software on that machine. So you got one server, you put in a USB key or not a USB key, but a printer port key. So in that server, and that server ran that software because the device key was on that key. So we could get that also for Kubernetes.
Yeah, if the device plugin. So one thing to add as well for the device API. So the behavior we're actually hoping to get to eventually is the behavior we have with PVC today, right? In PVC, you're not really saying, give me this brand of SSD. Mm-hmm. You basically say, I have a storage class that is defined at some level in my cluster, and I want this much storage with this behavior. Read, write many, read, write once, write only,
these characteristics,
only, right? So we want to interact with devices with characteristics, not with names or specific numbers. And I want 1/5 of a GPU kind of behavior that would be defined in the device. It's not going to be called probably device class, but device class will define that quality. And the underlying device would provide the API to say, I can be sliced into 50 pieces. I want 1/4 of that chunk. That kind of behavior is going to give us. So one thing right now, the way it works, you give the device access to the pod itself. But we don't necessarily need the entire pod to have access to the device. We could say, I have sidecars. I have 4 containers in my pod. Only one of the containers needs the GPU device or TPU device. Yep. The other 3 are monitoring. But right now, the way it works, when you attach it, all the containers now have access to the CUDA driver. And if you have a runaway container that you just added, because let's say, again, I'm not going to name any particular container. Let's say you just added a logging sidecar. Some malicious thing happened in the logging sidecar and that started looking for the CUDA API. If you add that today, that's going to be able to find the CUDA API. So the DRA work that is happening, that's going to be able to abstract that away to say only this container within my pod has access to GPU, but everything else doesn't.
Kost het beheer van Kubernetes je veel tijd en expertise? Maak kennis met ACC ICT. Zij ontzorgen je volledig met managed Kubernetes diensten op elke cloud. Gecertificeerde specialisten zorgen voor compleet beheer, 24/7 support en optimale beveiliging. Jij kunt je focussen op je core business, terwijl je Kubernetes-omgeving in betrouwbare handen is. Manage Kubernetes van ACC ICT. Jouw zorg, onze expertise. Bezoek accICT.com.
So it's also a lot of security.
Yeah.
Yeah, there is also a lot of security considerations, right?
Yeah.
So DRA stands for the dynamic resource allocation, just to be clear for people who doesn't know what DRA is, and it's essentially the work that is happening to make that abstraction layer Mofi is talking about possible. Yeah. But yes, back to your question, there is also a lot of security considerations, right?
Like one more other thing, like over the last, at this point, 10 plus years, right? We've been telling people, let's build your container. Let's not do user root. Let's make sure like we're in the user space. The moment you go to like this kind of hardware that is running directly on the node, you can no longer be on the user space. You have to have the root permission. So with the device DRA, there is also the consideration of how can we bring the API compatibility without having to drop down to the root layer.
Yeah, all the security stuff we've been doing for rootless access now are blown off the water because of...
it came in and immediately and things like build small containers. That's another one we kind of gave up on halfway through.
Oh, yeah, because what was the size of a VLLM?
So VLLM base image, I think roughly about 4 gigabyte plus if you're using something like, there is one model also of running, like putting the model weights inside the container, then all bets are off. Your container could be as big as 700 gigabyte.
Yeah. So
okay, let's run that.
Yeah, exactly.
So,
good luck.
Let's run that 50 times.
Yeah, and that's what most of this. I mean, most of the companies that run LLMs today as an API do that, right?
Oh yeah.
Yeah. I mean, companies like Anthropic, they run on Kubernetes, and they are running as SaaS software. So they have an API, and you just like talk to Claude, but behind they're not running one instance; they're running thousands of instances because they have to handle traffic for a lot of users, right?
Yeah, so that Claude weights has to be copied in.
All of those instances have then a connection to the model, I think. Or
I mean, all the GPU that they're using and TPUs they're using would have to have a copy of the model weights, which is the actual brains of the model.
Yeah. So the model is inside the container and it's loaded into the memory of the GPU.
Ooh. But that doesn't scale.
No, it doesn't.
Yeah.
So that was the whole point of our talk, right? Is how do you scale this?
Yeah. And how do you scale that then?
So you could do certain things, but it's kind of like you're kind of doing some trade-off between, because like, let's say you don't. So let's back up for 1 second. If you want to serve a model as an inference server, the model weights has to be inside the device that you're serving from. That part you can get away with. You could not do like a remote call onto a model weight because model weights by itself are just numbers. They mean nothing.
No.
Right? Until you put into a GPU and can do the communication. Input comes in, I run through the math, and output comes out. So that kind of, we can get away from that problem. Right? And another thing is like this large language models get better as they grow in size.
Yeah.
So like we're also not seeing any kind of like plateauing of like, we thought at some point like models won't get any better as we make them bigger, but we just like keep making them bigger. It keeps getting better. So we're gonna continue on that trend until we find that plateau point. So that's not a part we can get away from. But the things we can improve on is that instead of downloading that from some sort of a remote repository every time, can we preload that? Can we cache that into our system? So when a new container comes up, they can just copy it from a local-ish storage rather than going off to the internet and downloading it. That's one of the things we can improve upon.
Can't we? Because in the past we had streaming applications. Mm-hmm. Do you know that?
Yeah.
Can't we stream a model? A part of the model to the container during the operation.
So the issue with that particular thing, again, especially in GK and some of the other providers, we have an idea of image streaming, right, for the container image itself, because container image is a layer file system. You could kind of layer by layer. The issue with model weights, especially on the large models that are like a single model, you wouldn't be able to do that because model weights, you don't know what part of what path the input is going to take to get to the output. You need the whole weights. Yeah. There are some techniques in the inference that's called the mixture of experts, where you can basically combine multiple models into making a one thing.
Was my next question, because I saw that you could do a small model, and that small model talks to a bigger model, and that model talks to another big model, and that.
Yeah, so that's the mixture of experts, right?
Yeah. There is like that one technique. There's another technique of like using LoRa fine-tuned. You can use a LoRa layer on top, and that's, I think I'm going to actually push that question after Abdel because this is like a perfect tee up for Inference Gateway.
Yeah.
Right? You could kind of set up like a path gateway which says if question is coming into this path, use this particular LoRa, which is very small layer, like 4 or some like very small size that you can put on top of your model to answer questions on a fine-tuned manner.
Yeah, so LoRa stands for, lower ranking adaptation. Yeah. So it's a technique basically that allows you to, instead of fine-tuning a model for a specific task, you run a standard LLM, and then you run those LoRa adapters, we call them, and you can think about them as adaptation layers. So the adaptation layers are trained or fine-tuned for specific tasks. Right? You might have one layer that talks Japanese. You might have one layer that does math. You might have one layer that does coding. And then they all use a standard LLM under the hood, right? And you can think about it as the LLM knows how to process the inputs, but then the adaptation layer is specialized in one task. And so your query goes through both the LLM and the adaptation layer, and then you get an output out of it, right? Today, in order to do that, one of the only ways that I'm aware of is you run... First, you need a model server that supports LoRa adapters. And then you specify your model, like the actual LLM, and then all the available adapters. And then, when you send your request, then the LLM will decide which adapters to use based on the input, right? That's how we do it today. It's kind of clunky in the way it works. It's doable. TGI, the text generation interface from Hugging Face, supports that, for example. So the community in Kubernetes is working on this thing called the Gateway API Inference Extension. So the Gateway API is a project, right?
Yeah,
I think people
we've talked about it in a previous podcast.
Yeah,
yesterday.
Oh, cool. So there is an extension to the Gateway API to support inference workloads specifically, right? Why would you ask that? Well, it's very simple. The Gateway API is designed for web applications. Web applications are short, frequent requests. You make a request, you can answer. You make a request, you can answer. LLMs requests are not like that. LLMs requests are long. The prompt could be long.
Yeah.
And then also the output of the LLM could be long. You might sign the prompt and actually stream back the answer as the LLM is producing it, right? Mm-hmm. Your prompt sometimes could not be text. It could be audio. It could be video. They could be both, like the input and output are not always text because there are LLMs that, understand video, audio, pictures, whatever, right? So this extension, inference extension, is designed to handle these special use cases. And so one of them is the example that Mofi talked about, which is the LoRa adapters. Essentially expose a single endpoint that the users talk to, and then based on the inputs, then we know to which adapter we can route the actual requests. And with this, you're actually sort of decoupling the platform side from the machine learning side. So the platform engineers will configure the load balancer using the Gateway API inference extension, and then with the policies to say, if the request is coming to this model, you route it there. If the request is a text summarization request, you route it to this place. If the request is a stable diffusion, you route it to this model. So you can have a single endpoint and then multiple policies that will route to the specific model depending on how they configure it.
That's awesome.
Yeah. So this is a work in progress. We did a talk about it with somebody from Solo at the AI collocated event. So the video will be on YouTube. And the project itself is in kind of experimental mode right now. And then there is also the community is kind of working on building that and also integrating it into, there is like some Envoy work that is happening to integrate that into Envoy, because, the Gateway API is the API side. So there is also the data plane that we need to figure out, right? So that's also happening. And so this is actually one of the things I'm very excited about. There will be a lot of things coming out. So at the very basic, it's model-based routing. So we route based on the model name. And it's also like a way to route traffic based on how busy the backends are. So you can, if you have multiple LLMs running, you can actually route traffic to the LLM that is the less busy, right? Because the traffic is not your typical web traffic. So you cannot autoscale or do routing based on traditional metrics like CPU utilization and memory utilization, right? No. You need other type of metrics, right? Yeah. And so, that's the inference gateway.
Yeah.
Yeah.
Just to add on the you cannot do traditional scaling anymore, because in traditional one you could either look at CPU or RAM utilization, or we could say something like this particular endpoint is doing X many requests per second. But in the GPU world, because your input and output can be widely different in size, how big they are, just because this particular endpoint is serving one request, but that one request could be like 128,000 context window.
But
right?
he still uses CPUs.
It does. But
And so you could.
But that's not a good enough metric, because in a system like serving large language model, your bottleneck is almost never CPU and RAM. It's almost always your accelerator, right? So you want to look at how much of your accelerator is being utilized. And that is counted something like looking at the KV cache, like how much of the cache is being filled up, how much of that is like now like pressure of the cache. So you could look at the GPU and TPU utilization, and those are not yet perfect to the point where you can just look at one of the metrics and be like, that's the one I'm going to target, because depending on the type of model you're serving, the type of ones you look at are also kind of changes. So you have to look at multiple metrics together to find out the best possible path to route it.
You need AI for the metrics of the AI.
Potentially.
Yeah.
Actually, I can. If the people who are going to listen to this, they can do this. There's very easy test to do of what Mofi was talking about. Install Ollama on your laptop, and let's say you're using one of those new MacBooks that have a built-in GPU. So Ollama will actually be able to use it, right?
Yeah.
And then install those plugins that show you like CPU and memory utilization.
Yeah.
And install Ollama, run an LLM locally, and send a bunch of requests. You will see that your CPU will spike out. You will see actually spikes for each request you're making. Because what happens is that you are sending a request to Ollama itself, which consumes CPU, and then it sends it to the GPU. So you cannot autoscale on CPU because it will be too spiky, right? So that's not a good enough metric.
No.
So you need something else. So what Mofi was talking about, the KV cache utilization, the queue size, for example, is another one. A lot of LLMs, they queue answer requests. So they are not like processing them as they're coming. They will like batch them in a way, put them in a queue, and then process them.
Batch them in a way. So if you've got 5 people asking a question, he will send that 5 questions at once?
Yes. Because LLMs actually, they're not good at parallelization. They cannot run multiple requests in parallel. They just like run in a sequential way. So they depending on the model server, there might be a batch somewhere where they will batch requests and then process them in one go.
Oh, that's differently than I thought that would work.
Yeah. And so if you look at TGI, for example, the text generation interface from Hugging Face, if you install TGI, it does have a queue size metric you can export. So you can look at the queue, and the queue tells you how many requests are pending to be processed. And that's one metric you could autoscale based on as well, right?
Yeah.
So it's like the whole point of this is just to say LLMs have some very special considerations that you have to keep in mind. They're not your typical web applications, right? So all the stuff that we've been doing to optimize and autoscale web applications, put that on the side.
That's easy.
That's easy. Yeah, exactly.
Easy stuff.
At this stage, that's easy. Yeah, exactly.
Oh, that's awesome. And you said, so networking is also an issue because you need to pull in big models.
Yes.
Storage is an issue because you need to pull in big models.
Yes.
Yeah.
So batching. And what else do we need then for an LLM? Is that it?
The accelerators, obviously. Memory and CPU is almost never a problem. Or
especially like talking about cloud, right? Like if you're using that on your own device, you might have like a low CPU and RAM available. But in the cloud, pretty much any cloud provider, when they have like a GPU node, generally speaking, each GPU node has just so much CPU and RAM. Because in terms of like if you think of as a point of view of a provider, GPU is the biggest cost.
Yeah.
Right.
Yep.
So like throwing a bunch of CPU on that same node, it doesn't even like affect your graph. If you put like a cluster, like a GPU cluster, and that has like a 200 core CPU versus 150 core CPU, that is probably not even going to show up in the graph of the cost because GPU is just so much more expensive. So usually they're scaled, at least the cloud providers are scaled accordingly. So you never will be bottlenecked by GPU or CPU or RAM. You'll almost always be bottlenecked by your GPU and TPU.
Yeah. And then, there is other considerations. Like there is also security considerations, right? A lot of times what you want to do is you want to run some sort of pre-processing for the input to filter out any potential harmful input.
The guardrails.
Yeah, pre-processing for the output itself, right? So that could be another model actually that you run. There are actually specialized model that specialize in filtering harmful content.
Before you learn a model, or
It could be in multiple steps.
It could be multiple steps. It could be at the input and output. So typically, we see it at the input and output most of the time.
Pretty much. So you basically would say this request came in, and the question is asking itself is a harmful question. It's something could be right, and then you filter that out. And the model itself is it's a generative model which will sometimes hallucinate. So you can run another model before it goes up to your user that basically says, and there is actually
that grounds the response, maybe.
Yeah. Pretty interesting example of that you can actually see on like a Chat GPT or Gemini. If you go there, sometimes you'll put in a question, it will start streaming the output, and about like 2 lines in, it will basically stop that and show you I cannot answer that question. It basically halfway through, it's the other model that is looking at the streaming output goes like, okay, this output doesn't like qualify the bar we set for our own product. Right? Because again, companies like OpenAI, companies like Anthropic, companies like ourselves, Google, we want to make sure whatever we put on our name on it.
Yeah, of course.
Right.
And models are still predictive engines.
And they will continue to be that way.
Yes.
We'll never get to a object like non-predictive because it's in the name. It's
They're not
model.
deterministic. So
they will never be deterministic. Like actually, this is another fun thing. We actually get customers asking us this question: is that we're an enterprise, we need this model to respond the same way every time. And my answer to,
even we cannot make it respond the same way.
My answer to that question is you need a database. You want a database, but you're asking a large language. We have solutions for this kind of things. When you get the same answer every time, it's a database, not a large language model.
Yeah. So yeah, it's quite a lot of considerations to keep in mind when you're doing these kind of things. Yeah. So
awesome. That brings me to my final question.
Yeah.
We always ask, how do you see the future of Kubernetes or LLMs in this case? So
you want to?
I can take it. I can start.
Make the honor.
I think like anything, right? For example, just looking to the future is interesting, but also looking to the past is interesting. When Kubernetes first came out, we never thought we would run database on Kubernetes. For the first few years, we continuously said,
I always said, no, don't do it.
But in 2025 today, we have stateful set in the state where a lot of companies are successfully running databases on Kubernetes, right? So, and in the past 2 years, if we have shown anything that Kubernetes is really good at scaling and all the other behaviors Kubernetes has inherently, it makes it a really good place for auto-scaled large language model inference. So that is going to continue to be the device DRA stuff that we continue to pull out is going to make Kubernetes a really good place for any type of devices that you can think about. So the next 10 years of Kubernetes, I see, I don't think large language models are going anywhere. So we're going to continue to make that a really big priority for Kubernetes. And there is idea of rising tide lifts all ships, where making Kubernetes better for this kind of really wild use cases actually makes Kubernetes the platform much more robust for even other workloads. Once we can, for example, in Google, we released 65K node support on a single Kubernetes cluster. And that use case was mostly for training use cases. But one of our, the people that want to use it are not only just using training, they're using for batch workload. Because that just improved batch, not even GPU, TPU, just CPU batch, CPU bound batch. But because we're working on making training workload better, automatically other use cases also became easier. So in the next 10 years or so, whatever timeline you're thinking about, I think we're going to continuously improve on that, the most cutting edge, but that will also improve Kubernetes, the project for everything else underneath.
Yeah. I would before we go 10 years from now, we'll just go back, because you said you tell people don't run databases on Kubernetes. If we stop this podcast now and we go down to the exhibition hall, every other company does databases on Kubernetes as KubeCon, right? So 10 years ago it was a no-go probably, but now it's not a problem. We can do stateful workloads on Kubernetes. People know how to do that, right? But I think looking 10 years from now, Kubernetes itself have got to a maturity level where people just assume it's there. Just people assume it exists.
But it's still difficult.
I mean, it is very difficult. And it is a complex system. And you'll be, in my opinion, insane to manage it yourself today, right? Especially if you're a startup or a small company, right? There are companies that does self-manage Kubernetes, which is fine. But a small company shouldn't be doing that. But I think these improvements that Mofi was talking about that are specifically done for AI workloads are going to benefit the rest of the community, right? Autoscaling, a lot of improvement, autoscaling, like DRA, whatever, like all these things we've been talking about. I mean, I can give you a very concrete example. We didn't talk about it. One of the most common problems that people have been discussing for a while is how many clusters is the right number of clusters, right? Do you do multi-tenancy, you run multiple things in the same cluster, or do you do single clusters? So the whole problem of multi-cluster management have been an issue for a very long time. And we just open sourced MCO, the multi-cluster orchestrator, at KubeCon, right? Yeah. So MCO is coming out of we need to run at a large scale at potentially multiple clusters, and then have a single way of managing them, right? So again, this is done for batch, high-scale, kind of AI, ML data workloads, but it is going to benefit everybody else who's not doing those kind of workloads because you still need to run multiple clusters and you still need a standard way of managing them, right? So I think that the future is looking like a lot of focus on AI, ML, and a lot of things are going to trickle down to Kubernetes itself and just make it better.
So awesome. Now, I've learned a lot. Thank you very much.
Yeah, I appreciate it.
Thank you for having us. Thank you.
Thank you. Okay, bye-bye.
Deze podcast is een initiatief van ACC ICT en wij zijn te beluisteren op onze website k8spodcast.nl via Spotify, Apple en alle andere favoriete podcastproviders.